All right, number 18, we have 5 parts. We want to determine if the statements A through E are true, give an explanation or counterexample. So for first part, we are given f of x is equal to x squared minus 4x plus 100, and g of x is equal to x cubed minus 4x minus 100. It says these are antiderivatives of the same functions. So the way you can test that is just take the derivative of both of those functions, and if you get the same thing, then you can verify. Now I can go ahead and say yes, because I can see that the first part is the same, and the constant, they only differ by a constant, which is what usually happens when you take the antiderivative. You just get a difference of a constant when that constant goes to 0. So if we take the derivative, if we find f of x, little f of x, that would be 3x squared minus 4, and then the constant goes to 0. When you take the derivative of capital G of x, you get little g, and that will give us 3x squared minus 4, and then the constant goes to 0. So the fact that you get the same thing says yes. So we'll say the statement is true. For the derivatives, both of them, you get 3x squared minus 4. Big F prime of x is equal to little f of x. Then f is the antiderivative of f. No. F is the derivative. The way they're using these, f prime is equal to little f of x. Then f is the antiderivative of f. No, that won't be right. That would be the derivative. Statement is false because the antiderivative of f may vary. No. The statement is false because the function f is an antiderivative of little f on the interval, provided that is true. So B is the one that's going to follow based on the definition. Big F prime of x is equal to little f of x. Then the integral of little f of x is going to be big F of x plus c. That's true. Definition of integral, the statement is true. F is antiderivative. F is antiderivative on an interval, and f plus c determined by f is in the family of antiderivatives. That looks good. This one says f is an antiderivative. C is an arbitrary constant, is in the family of antiderivatives of f. What is the difference in these two statements? Okay, so this is saying determine, it's not determined by f. I think that's going to be the difference. We might not know what that is. D, we have these two, and it says they are derivatives of the same function. That f of x and g of x, this one has plus 3 and this has minus 4. These are derivatives of the same function. That would not be true. Derivatives of the same function would give you the same exact value, and they differ by a constant. They could be antiderivatives, but they cannot be derivatives. Statement is false. Integral of one is equal to this, and the integral of the other one is equal to this. That looks good. You can say C and K are two functions, and these are not equal. That would be good. Statement is false. Can only have one antiderivative. That's not necessarily this case. Many antiderivatives depending on the value of C. A looks the best. And then E, f prime is equal to g prime, then fx is equal to g of x. That one, may not necessarily be true. Okay, we can have the same derivative in two different originating functions. They can differ by a constant. So this is not going to be true. This is going to be false. No, that's not the one. False. Consider x and x plus 1. That works. Both of them have a derivative of 1, but they're not equal. So C shows that. So just properties of derivatives and antiderivatives.